Hi, today I'm going to take you through two questions, explain the history of the generations of computers and the evolution of the Intel and ARM architecture. So beginning with number one, computer generations. We're going to start with the first generation. Technology was dawning during the 1940s, and it was around 1946 when we got the first generation of computers. These computers used vacuum tubes as their main components. Now, what are vacuum tubes? Vacuum tubes, also known as thermionic valves, they are electronic components that consist of a sealed glass from which most of the air has been removed. Inside the tube, there are electrons, typically a cathode, a diode, and one or more additional electrodes. Their operation relied on the flow of electrons from the heated cathode to the positively charged anode, which is known as a thermionic emission. This electron flow can be controlled and amplified, making vacuum tubes suitable for applications such as signal amplification, switching, and signal generation. Okay, so vacuum tubes were large, bulky, and consumed a lot of power. Now this could be like setbacks for vacuum tubes. These computers that choose vacuum tubes are also very slow and unreliable because of the above mentioned. And the first generation computers mainly performed arithmetic calculations with the help of vacuum tubes. There was real need for improvement here. Programming them was terribly troublesome, and there was a desperate need for improvement. Some of the first generation computers include the ENIAC, EDVAC, and UNIVAC 1. These lasted up to about 1956, where they had to come to the end of the support. Some of the setbacks include, like additional to the ones I mentioned above, the high maintenance cost, the lack of user-friendly interfaces, limited memory, the cost of manufacture, limited applications, large size, even the space was too much. Like imagine one computer takes up a whole room. It's a no-brainer. Okay, now second generation of computers. So it wasn't until around 1957 that the second generation of computers were introduced. These used transistors and a magnetic core instead of vacuum tubes. Now, what are transistors? Transistors are semiconductor devices that play a fundamental role in modern electronics. They serve as electronic switches and amplifiers, controlling the flow of electrical current within a circuit. Transistors are typically made from semiconductor materials such as silicon and come in various types, with most common being bipolar junction transistors and field effect transistors. So transistors have a switching function since they can allow an on-off state. So what this means is they can be like a switch within a circuit. They can turn on or off themselves depending on the need. Then they also have an amplification function, as they can also amplify electrical signals by applying a small input voltage of current to the transistor's control terminal. It can control a much larger current flowing between its other terminals. Transistors revolutionized the field of electronics and have allowed for the miniaturization and increased efficiency of electronic devices. Now, advantages of the transistors, of course, include they were smaller, faster, and more reliable than vacuum tubes. This led to smaller and more efficient computers. Now, some of these include the IBM 1790, the UNIVAC 2, and more of the advantages of the transistors include a better language use, obviously. Now here we're using assembly language, which was used instead of machine code, and this drastically reduced the cost of the computers, since it was much higher to produce vacuum tubes in a commercial purpose. And then the commercial production still being high, despite being long than the one for the first generations. That's a disadvantage. Then there is a punch cards for input. They also only had a specific purpose. They required frequent maintenance, yes, and so on. Now, that generation. So, as technology improved in 1965, the third generation of computers was also introduced, and these used integrated circuits. Integrated circuits were made up of multiple transistors. Now, what are integrated circuits in detail? So integrated circuits are known as chips, and they are miniaturized electronic circuits that contain a number of electronic components, including transistors, resistors, capacitors, and diodes, all fabricated on a single semiconductor substrate, typically made of silicon. These components are interconnected in complex network to perform specific functions or tasks. Integrated circuits come in various forms, such as microprocessors, memory chips, and various types of specialized chips. And then now, because of the improvement we had in the third generation, these computers were smaller, faster, and more reliable than the second generation. Some of the advantages we enjoyed include the introduction of high-level programming languages, the introduction of a mouse and a keyboard as a replacement for the punch cards, a higher storage capacity, they occupied less space due to the use of integrated circuits, and above all, the computers were now portable, meaning they could now be used personally. This is beautiful. For the setbacks, maintaining the integrated circuit was difficult, and these computers still required air conditioning for cooling. Some of the third generation computers include the IBM 360 and the CDC 6600. And it wasn't until around 1972 that the fourth generation came in. Let's hop in and see that. So, fourth generation. Firstly, these computers used microprocessors. Now, microprocessors are integrated circuits that contain the entire central processing unit on a single silicon chip. More on that. It is a highly integrated device that executes instructions and performs calculations for various tasks. Microprocessors are a crucial component in most computing devices, from personal computers to smartphones, embedded systems, and more. Today, microprocessors are the heart of virtually all digital devices, making them one of the most important components in modern technology. They enable computers to execute complex tasks, run software applications, and provide the computing power for a wide range of applications, from basic calculations to advanced data processing and visual intelligence, which is really good. And then again, on the advantages, of course, as an improvement to the third generation, this led to an even smaller, more affordable, and more powerful computers. Actually, this generation is the one that introduced the first supercomputers. More of the advantages we enjoyed were networking between systems was invented, the memory and storage of the computers increased drastically, multiple high-level languages like BASIC, Pascal, COBOL, Fortran and C. A great improvement in processing power. This was a plus. A more affordable cost, multiple purposes, reduction in maintenance cost, and so on. This generation had so much to offer. Some of the setbacks include the high level of technology used to make microprocessors, sadly. But then some of the fourth generation computers include the Apple II and the IBM PC. Let's get a look at the fifth generation now. So yeah, fifth generation. So later, around 1978, a fifth generation of computers were introduced, and obviously that is the generation we're still using today. So these computers use parallel processing, artificial intelligence, and quantum computing. So more on the things they use. Parallel processing allows computers to perform multiple tasks at the same time. Artificial intelligence allows computers to learn and make decisions on their own. As you can see, some of the trends going on these days. There's autonomous driving, there's ChatGPT. These days, AI can literally do anything for you. Quantum computing is a new type of computing that uses the principles of quantum mechanics, obviously on a computer scale. And then modern high-level languages such as Python, Ruby, Java, and many more have been introduced. Now this makes programming way easier than before. Then the main goal of these is to create computers that can organize themselves, think like humans, and do much more. One of the main advantages we enjoy is superconductor technology. And some of the fifth generation computers include the Deep Blue supercomputer and the Watson computer. Okay, that was question 1. Now for question 2. The Intel x86 architecture. Now the Intel x86 architecture. So this architecture is also known as the IA32 architecture, and it has its origin dating back to the late 1970s. It was developed by Intel Corporation, primarily by a team led by John H. Crawford. The x86 architecture's lineage was traced back to the Intel 8086 microprocessor, which was introduced in 1978. The 8060 was a 16-bit microprocessor and marked a significant departure from Intel's previous 8-bit processors. Now, I know you may not need this history, but it's going to help you understand the evolution of this architecture. And then over the years, Intel continued to evolve the x86 architecture with the introduction of various processors like the 8286, the 8386, the 8486, and eventually the Pentium series. These days we have the i9. So each generation brought improvements in performance and capabilities, making x86 processors the dominant architecture in the present computer market. The x86 architecture has also expanded to support 64-bit processing, which allows for more memory and faster performance. The first 64-bit x86 processor was the AMD Athlon 64, released in 2003. Intel followed with its own 64-bit x86 processor, the Pentium 4 Extreme Edition. Later that year, the 64-bit x86 processors, also known as the x86-64 or AMD 64 or Intel 64, and they are backward compatible with 32-bit and 16-bit x86 processors. The x86 architecture has been the basis for many innovations and developments in the computer industry. For example, The x86 architecture enabled the creation of the IBM PC and its clones, which became the dominant platform for personal computing. The x86 architecture also allowed for the development of operating systems such as MS-DOS, Windows, Linux, and macOS, which run on millions of computers around the world. The x86 architecture is also widely used in embedded systems such as smartphones, tablets, routers, and game consoles. This architecture is not without its challenges and limitations. However, some of the drawbacks of the x86 architecture include its complex instruction set, which makes it difficult to optimize it and debug. This architecture also suffers from legacy issues such as the segmentation model, the lack of general purpose registers, and a limited instruction length. This architecture also faces competition from other architectures such as ARM, RISC-V, and MIPS, which offer simpler and more efficient designs. Despite these challenges, this architecture remains a powerful and versatile platform for computing as it continues to evolve and improve with new features and extensions such as multi-core processing, virtualization, security, and parallelism. This architecture also benefits from a large, diverse ecosystem of hardware and software vendors, developers, and users. This architecture has been tested and is proven to be adaptable and resilient over the years. It is likely to remain a dominant force in the computer industry for the foreseeable future. Now let's take a look at the ARM architecture. I think it's a more interesting one. So as for the ARM architecture, its origins are traced back to the 1980s when a British company called Acorn Computers Limited was developing a new microprocessor for its personal computers. The company hired two talented computer scientists, Sophie Wilson and Steve Farber, who designed the first ARM processor, the ARM1, in 1985. This chip was used for internal research and development, and it featured a 32-bit internal structure but a 26-bit address space, which is limited to 64 MB of memory. This ARM architecture evolved over several generations, adding new features and enhancements to improve performance, power efficiency, and functionality. Some of the notable milestones in the history of ARM are the ARM6 processor, released in 1991, and was the first to implement 32-bit ARM version 3 instruction set. It is also added a coprocessor interface, which allowed the use of external coprocessors such as the floating point units. Then the ARM7 processor, released in 1993, was the first to use a superscalar pipeline, which enabled it to execute more than one instruction per clock cycle. It also added a 16-bit instruction set called Thumb, which reduced code size and improved code density. The ARM9 processor family, released in 1995, introduced a Harvard architecture which separated the instruction and data caches. It also added a fast multiplier and a debug unit. The ARM9 family included several variants with different features and performance levels, such as the ARM9 TDMI, which added an enhanced Thumb instruction set and a Giselle extension for Java bytecode execution. The ARM10 processor family, released in 1999, introduced a very long instruction word VLIW architecture, which allowed parallel execution of multiple instructions in a single cycle. The VLIW stands for Very Long Instruction Word, the short form. And then this processor also added a SMID extension called Wireless MMX, which improved multimedia performance. The ARM11 processor family, released in 2002, introduced an out-of-order execution engine, which increased instruction level parallelism and performance. It also added a vector floating point coprocessor, termed as VFP, and a trust zone security extension. The Cortex-A processor family, released in 2005, introduced a new microarchitecture design that optimized performance, power efficiency, and scalability. It also added several new instruction sets and extensions, such as Neon for advanced SMID operations, VFP version 3 for double precision floating point arithmetic, Thumb2 for enhanced code density and performance, and SVE for scalable vector processing. The ARM version 8-A architecture family, released in 2011, introduced support for 64-bit address space and 64-bit arithmetic with its new AArch64 instruction set. It also added several new features and enhancements to improve security, virtualization, reliability, and energy efficiency. And as I told you, this is the more interesting one. Ideally, if you look into it, currently, the best personal computer you can get has an ARM chip, which is the M2 chip made by Apple. Yes, that was it on those two questions. See you next time.